In this video, we're going to look at law of cosines, and in these typically you will either be given all three sides of a triangle and none of the angles, or you might be given a couple of sides and the angle in between. I drew a real rough sketch of a triangle above. Again, capital letters for the vertices, lowercase for the lengths of the opposing sides. Any one of those three equations that have the braces around it, you're free to use. You'll want to pay attention to what you're given and use that to try and at least make your problem easier as far as solving. If you're given all three sides, like the example we're about to do, it honestly doesn't matter which of those three equations you pick. It just matters what angle you want to find first. So suppose you wanted to find angle A first, you would use the very top equation over there in your upper right. And so let's just do that. All right, so let's set this up. We have, it might not hurt for me to draw the triangle anyway. Let me do that real quick, just to give you a visual. Again, don't expect these to be to scale. I just draw them for illustration purposes. All right, so we got 8, 6, and 3. All right, again, not drawn to scale, but just drawn so we can at least get the sides labeled. Let's suppose we want to find angle A first. Okay, so that one would be the top equation in the braces towards the top right of your slide. So we're going to see, when we set this up, it's going to be 6 squared equals 3 squared plus 8 squared minus 2 times 3 times 8 times cosine of A. If it helps to remember, up here in your formulas, whatever letter is on the far side of the equation, its opposing angle will be at the other end. Notice how if it starts with a B, it ends with a B. If it starts with a C, it ends with a C. That's true for all three equations. Okay, well, let's start solving. And we're going to get 36 equals 9 plus 64 minus 2 times 3 times 8, that's 48, cosine of A. Okay, if we subtract 9 and 64, so let's do 36 minus 9 minus 64, that's negative 37, equals negative 48, cosine A. Divide both sides by negative 48. Those two negatives will make a positive. 37's prime, so it's not going to reduce any. And then finally, to get A, we do cosine inverse of that fraction. Cosine inverse of 37 over 48. And again, make sure you're in degree mode. Second cosine, in the parentheses, 37 divided by 48, and I get 39. Let me check the rounding on here. All right, WebAssign's asking us to round to 2 decimal places, so 39.57. degrees. Okay, I'm going to go ahead and label that. Okay. Now, at this point, you can revert back to law of sines to get angle B. Now, if you wanted to stick with law of cosines and you wanted to find angle B next, you would use the middle equation in the braces at the top right of your screen. Once you know an angle, then we can go into back to law of sines. I'm going to go ahead and on the next slide just find the angle B through law of cosines again, just so that we have extra practice with these equations. All right, so I went ahead and recopied the progress we had made so far on our triangle. We just found angle A. We could go back to law of sines to find either B or C. I'm just going to choose to stick with law of cosines. Specifically, I want to find angle B next. And then just as a reminder, that middle equation was B squared equals A squared plus C squared minus 2AC times the cosine of B. So that's 3 squared equals 6 squared plus 8 squared minus 2 times 6 times 8 cosine of B. Once we figure out angle B, then we can just subtract A and B from 180, and that'll give us C. Okay, so got everything subbed in. Be careful with the calculations. 9 equals 36 plus 64 minus, what's 12 times 8? 96 cosine of B. Okay, so let's take 9 minus 36 minus 64. That's going to give us negative 91 equals negative 96 cosine of B. Divide both sides by negative 96. That'll make a positive 91 over 96. And then cosine inverse of this fraction will give us angle B, which is to 2 decimal places. Second cosine in the parentheses 91 divided by 96. I get 18.57 degrees. Now, anytime you know 2 angles in a triangle from subtraction, you can get the third. So let's see, angle C is 180 minus the 2 that we've solved, 39.57 minus the other one, 18.57, for a grand total of angle C is approximately, because those second 2 decimals are approximated, 39.57 subtract minus 18.57, I get 121.86. Let's do an extra example of law of cosines. In this diagram, we have side angle side. Specifically, side B is 13, angle A is 30 degrees, and side C is 26. So this is side angle side. Let's first find, well, since we know angle A, it would make sense to go after side A. Let's do that. Back on the first slide, and I'm going to write the formula down just as a reminder. If we're going after A, we'll put it first, and then we'll have B squared plus C squared minus 2BC cosine A. We have the values for everything except lowercase a, but that's okay. That's what we're trying to solve. All right, so B is 13. C is 26. Two times 13 times 26 cosine A. Yeah, I'm going to have to get the calculator out for this one. All right, so we've got A squared equals, let's see, I can handle 13 squared. That's 169. 26 squared, 676. Minus 2 times 13 times 26. That's 676. Cosine A. 169 plus 676. Be careful not to subtract that 676 that's attached to cosine A. We just want to get a total on those first two numbers. So A squared equals 845 minus 676. I tell you what, I don't know why I didn't do this earlier. Let me go back and I'm just going to take capital A, which I should have done in the first place, and just replace that with a 30 degrees. Can't believe I overlooked that. Oh well, practice makes permanent, doesn't make perfect. So technically, if I hadn't have goofed this up halfway through, you could have already typed the entire right side in at this level. You could have typed that in all at once. And feel free to do that on your homework examples. You don't have to drag these out step by step. Okay, 845 minus 676 cosine 30. I get A squared equal to 2, and I'm going to carry several decimal numbers out. 259.566827. Square root of all that, hang on to your decimals so your final answer is accurate. The square root of that 259 number is 16.11. There we go. Now we know all three sides. Let's start going after the angles. Let's do angle B. All right, so if we go after angle B, then we need B squared, which is 13 squared, Let me do that in blue. 13 squared is equal to a squared plus c squared c is 26 minus 2 times those numbers cosine b okay. All right, so if I don't want to switch slides, I've got to be pretty methodical here. Okay, so I'm going to do 13 squared minus 16.11 squared minus 26 squared. That gives me negative 766.5321 equals, now this negative 2 times 16.11 times 26, that gives me a negative 837.72 cosine B. Okay, so B is going to be cosine inverse of, and again, when we divide by negative 837.72, those two negatives are going to make a positive. So two negatives make a positive if they're in the same fraction. 766.5321 over 837.72. All right, second cosine, and I'm going to put these numbers in. 1 divided by 837.72. Okay, so I get 23.79. I'm going to go up here and mark B with that. 23.79. And then finally, C, we can just, I'm going to sneak that in green. Actually in red, red will show up better. C is equal to 180 minus the two angles that we found. 30 was given, minus the angle we just found, 2379. For a grand total of, let's see, 150. I'm going to go ahead and mentally subtract those, minus 23.79. I get 126.21. All right. So the law of cosines equations are fairly long. The good things about them is the interior parts are always the same. Like if it's a squared plus b squared, it's going to be minus 2ab. Those letters in the middle will always match each other. The letters on the far end will also match each other. But your formula sheet is in Google Drive, so feel free to use it as much as you need. And just be careful when you're solving these. And on the next slide, we're going to do one where we use Heron's area formula, and this is a case of where you're given all three sides of a triangle. Instead of side angle side, you'll just have all three sides given, and we'll look at that formula. Let me write that up here. Heron's formula allows you to find the area of any triangle if you know all three sides' lengths. the area formula is quite complicated to look at first. It's square root, and everything under there, lowercase s, is called a semi-perimeter. It's half of the sum of all three side lengths. And so it's going to stand alone under the radical as an s. And then you have three consecutive sets of parentheses where you take the semi-perimeter and subtract each of the three sides one at a time from it. Multiply all that together, take the square root, and you've got your area. So anytime you're asked to find the area of a triangle using Heron's formula, your first move is to find the semi-perimeter. So that's what we're going to find first. If I can get my Apple Pen to work. Come on. There we go. Alright, so I'm going to try it again. There we go. I think my battery had run out on my Apple Pen. Half of the sum of the three sides Okay, so if we add up all three sides, and you can do this without even drawing the triangle out. You don't have to diagram it. Feel free to do it if you like. Okay, 4 plus 13 is 17, plus 15, I believe that's 32. Let me double check. Yep. Half of 32 is 16. Okay, so S is 16. We're going to need to remember that value. Okay, so now we go in for the area. Really long square root. 16. 16 minus A. And all this is multiplied. 16 minus 13. And finally 16 minus 15. If you're careful, you can type this in all at once. If you prefer to simplify a little bit at a time, that's fine too. Just pick whichever way you want to do it and be careful. I'm going to go ahead and write out all the results. So we've got 16 times 12 times 3 times 1, which is square root of... Now again, you can just power through it all and just start your square root, multiply all the way through. That's fine. You don't have to do every single step like I'm doing. 16 times 12 times 3 times 1, I get 576. And then the square root of that is 24. Come right out on the dot. I can't believe it. Alright, so this would be 24 square units, but that would be your area. Again, the first thing you want to do is add up the lengths of all three sides, cut that in half. That is your semi-perimeter, and you got to have it. And you might want to calculate it twice, but you got to have that right before you ever start plugging into the actual area formula, because it is used a total of 4 times.